Welcome to June 10th's LeetCode Challenge. My Calendar 1. Implement a My Calendar class to store your events. A new event can be added if the events will not cause a double booking. Your class will have a method book which takes in two parameters, int start and int end. Formally, this represents a booking on the half-open interval start end. The range of the real number x such that x is greater than or equal to start but less than n. A double booking happens when two events have some non-empty intersection, i.e. there is some time that is common between both events. For each event, for each call to the method myCalendar.book, return true if the event can be added to the calendar successfully without causing a double booking. Otherwise, return false and do not add the event to the calendar. And here the call will look like something similar to this. So let's go through this example here. So we initialize my calendar and we call the method booking, which adds the start of 10 and 20. So returns true because my booking, the booking is empty initially, and then we can add anytime we want. However, if we do a second call to the book method with start time 15 and end time 25, returns false because 15 is within the range of 10 and 20, and then so it doesn't add it to the event to the calendar. However, when we do the method call to book start time 20 and end 30, it returns true because even though 20 is listed right here, it's an open-end interval. So it means that it's not inclusive of 20. However, the start time is inclusive. So we're allowed to add 20 to 30, which returns true. So let's kind of copy this method here and let's see how we could kind of think through this. So we have, let's say, we'll make a list, a sorted list of some sort. So we have, let's say 10, 20, which will have a list of tuples which stores the start and end time. So initially it's empty, and we add a start and end time of 20 right there, 10, 20, and then we want to add, say, this is already included. If we want to add 15 and 25, we have to find out where it starts and where the start of our entry is and where the ending of our entry is, so that we just insert it directly into it in order. So you want to compare basically that, for instance, you want to compare the start of what we're entering to what's already there. So for instance, the start of our entry is less than the end of our original array, so we can't add something in like that. So this is how we're gonna approach the solution using well, we'll start off with brute force to see how it goes. So we could do something similar to, let's say we write our init function to be self.calendar, and we're going to make an array out of that, a list, I should say. And then we want to check for each start and end within self.calendar. That if the start is less than the end of what we're entering into a new booking, and the start is less than the ending of our of our booking start is less than the end of our whatever's in our calendar, then we'll want to return false because it's going to cause a double booking. However, return true, and that happens. If this condition is not met, then what we're gonna do is we're gonna add the start and end to our calendar. So self.calendar .append append a tuple, so it'd be start end, and then when we add it, obviously return true. Let's see if this works. Finish, true, true, false, true. Submit it to see how it goes. Awesome, that works. So time complexity wise, it would be we're searching through it, so it'll be big O of n squared, which is not terribly great. And then our space complexity would be big O of n, because we are using the number of spaces for each entry, right? Each booking. Each booking's our n value. However, can we do better? Can we speed it up a little bit, potentially? The answer would be yes. One way would be using a binary tree to store our to look up between to make it go a lot quicker. But I'm going to try a different path here. Let's see if it works. So we're going to rewrite our init function to be break it up into 2 points instead of having one. Instead of having a start and end tuple within our calendar, we're going to break it up into 2. We're going to do starts, an array for starts, and an array for n, self.n. So now we're breaking up our start and end dates, bookings, into two arrays. So we're going to modify it a bit, and we're going to use the bisect module that is built into Python. So the bisect module, if you don't know it very well, it gives you an index. So if you want to insert something into an already sorted list, it's good to use this bisect method, which gives you an index of where it's going to insert. So I'll type out the expression, and then I'll kind of describe it to you. So bisect dot bisect. So what it does is it takes in 2 parameters. First one being a list, so self.ends, and then it takes then the value of what it's gonna insert. So this right here, bisect, is actually bisecting into the right of the sorted list, and it gives you the index of where it's going to insert the start number into the end value here, end value array, the ends of an array. So if so we want to know if the index that we're inserting into equals the length of the self.n, the array of the ends, or if ends is less than or equal to self.starts at the index, then we want to return true, because this is what we want, because it's a scenario where we're not going to cause a double booking. However, before we return true, we need to add our start time, our start booking into the start array, and we need to add our end booking into our end array. So let's do that. Self.starts insert into an index and our start. So we use insert here to keep track of, because we do have access to the index number now, so we can actually insert directly into the position where it should fit in order to keep it sorted as well. We'll do the same thing with ends dot insert at index and end. Right, we have that, and then returning true. Otherwise, if this doesn't work, we're going to return false. Okay, let's see if this works. Oh, it runs. Okay, true or false. Okay, let's submit it. Alright, this works as well. So time complexity is at worst n squared. However, if you're lucky and you do have a certain arrangement, it could also be best case where it be O of n log n as well. However, space complexity is still it's actually 2n, big O of 2n, which simplifies down to big O of n still, with the number of entries, because number of entries of bookings we have. So yeah, this does speed up just a little bit. It's just another way of thinking about it. Another approach is using making another class nodes, and then you do your binary tree approach to it, which is very cumbersome for this short method. All right, that's it. Have a nice day. Until the next one.